Section 7.3, we're going to talk about powers of polynomials and something called difference of squares, whatever that is. Before we do that, I do want to do a little bit of review of section 7.1 and 7.2. In section 7.1, you learned what a polynomial is. What's a polynomial? How do you recognize a polynomial when you see one?
More than one exponent?
And there's something special about the exponents.
There's a power to it, really. Power.
Okay, so there are exponents, that's true, but the exponents have to be special kind of numbers. We have some that have exactly the power of 1. For example, if I had x squared plus 3x plus 5, that's a polynomial, but x to the negative 2 plus 3x plus 5 is not a polynomial. What's the difference in the two of them?
The variable powers are counting numbers.
The variable powers have to be counting numbers, which means the powers have to be 1, 2, 3, 4, 5. I can't have negative powers. I also couldn't have this. That would not be a polynomial. I'm not allowed to have fraction powers or decimal powers. Okay? So that's the key thing about polynomials. Polynomials have powers, but the powers are really, really nice numbers. They're 1, 2, 3, 4, 5, etc., etc. No negative numbers, no fractions, no decimals. Really, really nice numbers. All right, and then what we primarily did in section 7.1, we talked about adding and subtracting polynomials. So if I gave you something like x squared plus 3x plus 5, and I asked you to subtract 3x squared minus 2x plus 1, what would you do? How would you subtract those?
You would do the FOIL.
No, this is not
Oh,
FOIL.
my bad.
We're not. We take this negative sign and we distribute it through. We change all the signs over here. So we take the time to write it down. We write down x squared plus 3x plus 5, and then we run this minus sign through. That makes minus 3x squared plus 2x minus 1. So if we're subtracting, we take the time to write it down again so we don't make a mistake on our minus signs, and then we combine our like terms. And what do we mean by like terms?
So the x squared and 3x squared?
The x squared and the 3x squared, those are like terms. What makes them like?
Because they have x squared.
They have exactly the same variable and exactly the same power. They both have x squared. So what do you get when you take an x squared and you subtract a 3x squared?
Negative 2x squared.
Negative 2x squared. How about a 3x and a 2x? It makes a 5x. And 5 minus 1? 4. So there would be our answer. We added and subtracted our polynomials. Now in section 7.2, we talked about multiply. So how would I take 2x minus 3 and multiply that by x plus 6?
Take the first one and multiply, take the 2x and multiply by the x, and then multiply by the 6, and then take the negative 3 and multiply by the x, and multiply by the 6.
Exactly. All you're doing is you're doing the distributive property twice. You're going to take the 2x and you're going to multiply it by both of these, and then you're going to take the negative 3, multiply it by both of those, and then you add up all your like terms. So when I do that, what's 2x times x?
2x squared.
2x squared. 2x times 6? 12x. Negative 3 times x? Negative 3x. And negative 3 times 6? Negative 18. I look to see if I have any like terms. Do I have any like terms?
Yes.
You bet. I combine those together. That's 2x squared plus 9x minus 18. Questions on that? All right, so that brings us to section 7.3. What we're going to talk about first in section 7.3 is powers of polynomials. What do we mean by powers of polynomials? I'm not going to get rid of the exponents.
No, but that's what it means, really. Something to do with it.
Powers means exponents. So what it means is I'm going to take polynomials and I'm going to do more powers to them. For example, I might start with something like a monomial. I might take 3x squared. That's a monomial. Why is it a monomial? Only one term, monomial. And I might ask you to take 3x squared and square it. What does it mean to take 3x squared and square it?
Multiply 3x squared by itself.
You take 3x squared and you multiply it by 3x squared. That's what it means to square. To square means to multiply by itself. What's 3x squared times 3x squared?
9x to the fourth.
9x to the fourth. Excellent. Why 9x to the fourth? The 9 I understand. 3 times 3 is 9. Why x to the fourth? You got to add the exponents. You have 2 exponents here, 2 exponents there. Altogether that makes 4 exponents. That's correct.
And then there's ones where it's weird, I mean, it's drawn out to where you have to multiply the exponents. I remember doing those too. If there's an exponent inside a parentheses and there's one outside, you're supposed to multiply.
Okay. So what you're saying is,
I've seen those.
if I have an exponent inside and an exponent outside, 2 times 2 makes 4. You're exactly correct. What if I asked you to take negative 5x cubed and square that?
5x to the 9. 5x to the 6th.
One of those two. Which one?
6th.
Going to the 6th. Why 6th?
Oh no, we're going with 9.
Because instead of doing it the long way up there, you would just multiply the inside to the out.
Correct.
So 3 plus 3 would be 6, so 3 times 2 is very good.
So we squared the negative 5. Negative 5 squared is 25. X to the, you were right the first time and talked yourself out of it. It should be 6. When you have a power like this one, followed by another power like that one, you multiply those two powers together. Because if you think of this the long way, this would be negative 5x cubed times negative 5x cubed. Negative 5 times negative 5 is 25. And then x cubed means you have 3 x's. And then x cubed again means 3 more x's. So you've got 3 x's and 3 x's. Altogether you have 6 x's. So it should be x to the 6th. So when you have a power followed by another power, you multiply those powers. Should be a 6 there. Questions on that? All right, now, what if I gave you a binomial and asked you to square it? What's a binomial? 2 terms, so give me an example of a binomial.
3x plus 4.
3x plus 4 is a binomial. So I want to take 3x plus 4 and square it. How do I take 3x plus 4 and square it?
Multiply by itself.
That means, by definition, it means 3x plus 4 times 3x plus 4. That's what squaring means. Square means multiply by yourself. How do you do that? That's what we just did back in section 7.2, isn't it? We're going to take this 3x right here, and what are we going to do with it?
Multiply by 3x by 4.
We're going to distribute. We're going to multiply by the 3x and by the 4. And then I'm going to take this 4, and I'm going to distribute it. I'm going to multiply by the 3x, multiply by the 4, and I'll see what I have. All right, so I do that. What's 3x times 3x?
X squared.
9x squared. 3x times 4? 12x. Plus, now I take the 4. 4 times 3x? 12x. And finally, 4 times 4? 16. So I end up with 9x squared plus 24x plus 16. Questions on that? something I want you to notice. This is probably the single most common mistake made in all algebra classes. 3x plus 4, whole thing squared, does not equal 9x squared plus 16. Why not? Because it's not the right answer. The right answer is? All right, so what did I do to get this wrong answer? Well, that's true, I suppose. What I really did is I squared the first one, and I squared the second one. But that doesn't work. When you have a binomial like this with a square outside, unfortunately, you don't just get to square the first one and then square the last one.
I have a question, but why do you call it binomial?
Two things.
Oh, the 3x.
The 3x is one term,
And plus 4.
and the 4 is another term. So binomial means it has two terms.
Oh.
If I said trinomial, that would mean it would have three things. Yeah, that's all. Anyway, this is probably the single most common mistake in all algebra classes. People will write 3x plus 4 squared equals 9x squared plus 16. And what you're forgetting is when you multiply these together, you get these two pieces in the middle. And these two pieces in the middle don't cancel each other out. Questions on that? It's close, isn't it? 9x squared plus 16, 9x squared plus 16. It's close. Missing the stuff in the middle, though. Okay, how about 5x minus 2 squared? How would you take 5x minus 2 and square it? Times it by itself, okay. So I would write down 5x minus 2. 5x minus 2. What's 5x times 5x? 25x squared. 5x times negative 2. Negative 10x. Then I go to the negative 2. Negative 2 times 5x. Negative 10x. And negative 2 times negative 2. 4. Final answer. 25x squared minus 20x plus 4. Questions on that? Anybody notice a pattern?
Yeah, there's a negative 10x in the middle. I noticed.
So something to notice is, back up here, these two terms in the middle turned out to be exactly the same, didn't they? They both turned out to be 12x. And on this one, the two terms in the middle turned out to be exactly the same, negative 10x. All right, so there's a shortcut for these. If I had, I don't know, 4x plus 3 squared.
Times 2.
It'd be 12x and 12x.
Correct. So what are we going to have front? In front, we're going to take the 4x and we're going to
16x squared.
square it. That's going to be 16x squared. In the middle, we're going to have a 12x and
12x.
another 12x. 12x and 12x makes 24x. And then on the end, 3 squared is 9. So once you've done a few of these, if you happen to recognize that pattern, you can save yourself some work. You don't have to write it all down. All right, so let's do one with some numbers I haven't used yet. How about, what numbers haven't I used yet? I don't know. 8x minus 7 squared.
64x squared
60.
minus 112 plus 49.
You forgot one thing, minus 112x plus 49. And here's how he did that so fast. He said 8 squared is 64. Then he did the middles. He took 8 times 7. 8 times 7 is 56. But then you have to double it, because when you multiply, there's going to be 2 of them. So he did 8 times 7 was 56. And 56 times 2 is 112. And then it's a negative, because that one's a negative. If this is a positive, that one's a positive. And then he squared the 7. 7 squared is 49. So what you'll see in your book is you'll see some formulas, and these are called perfect squares. And it'll look like this. It'll say a plus b whole thing squared is a squared plus 2ab plus b squared. And conversely, a minus b whole thing squared is a squared minus 2ab plus b squared. And that's exactly the pattern that we just noticed, that you can just square the first one, multiply these two together, 4 times 3 is 12, and then double it, and you get 24, and then 3 squared is 9. Questions on that? Now, my experience is some students are very comfortable with formulas. Some students are very uncomfortable with formulas. So if I give you this problem on a quiz or a test, if I write 3x plus 8 squared, it's not going to insult me at all if you write 3x plus 8 times 3x plus 8 and then multiply it out. Because if you do that, probably 98 times out of 100 you'll get the right answer. Some students, like I say, are very good with formulas. Some would use the formula and just write the answer without showing me any work. Others need to write it down and show me the work. Do I care which way you do it? Not at all. Whichever way works for you. Our answer would be, we're going to have 9x squared. 8 times 3. And then I'm going to have an 8 times 3 again. 24 and 24 makes 48, so plus 48x. And then 8 squared. 64, so there's my answer. Questions on that? All right, here's the last thing in this section. What if I take 3x plus 8 and I tell you to multiply it by 3x minus 8? So notice those aren't exactly the same. What did I change? What did I change? Those aren't exactly the same. One has a plus and one has a minus. All right, so we multiply these. What do we get? 9x squared.
Minus 48?
No, minus 24x. Then I go to the 8. 8 times 3x is plus 24x minus 64. So something interesting happens. What's the interesting thing?
You just have to remember that one of the 24s is negative and one is positive.
And what happens when one is positive and one is negative? They cancel out. The middle two terms cancel out here, don't they? So what's left?
9x squared minus 64.
9x squared minus 64. Let's try another one. How about 2x minus 7, 2x plus 7. Again, notice that those two binomials, they're almost exactly the same, but one has a minus and one has a plus. You go ahead and you multiply those together. You get 4x squared plus 14x minus 14x minus 49. And what happens? The middle two ones cancel out, and you're left with 4x squared minus 49. All right, so once again, you might recognize there's a pattern. So if I were to give you 5x plus 4 times 5x minus 4, I would kind of hope you would just tell me the answer is 25x squared minus 16. Where'd the two middle terms go? They cancel each other out, don't they? there's a name for this, and there's a formula. The formula looks like a plus b times a minus b is a squared minus b squared. And this is called difference of squares. Why would you call that difference of squares? What does difference mean?
Subtract.
Difference means subtract. And what did we end up? We ended up with something squared minus something squared. That's why it's called a difference of squares. Okay? Again, some people like formulas, some people don't. If you don't like the formula, if you don't recognize this, then just go ahead and multiply it out and recognize that the middle two terms do kill each other. If you are good with formulas and you're good with looking at patterns and realizing, hey, I recognize this, the middle terms are going to cancel out, then that's all the work you need to show me. Okay? Questions on that?